Raza Habib, one of the co-founders of Humanloop, and today I want to talk to you guys about the best practices for building LLMs in production. So why am I qualified to comment on this? Over the last year, Humanloop has helped thousands of developers through our developer tools to build reliable applications on top of large language models like GPT-4 or Claude, or even people's own custom fine-tuned models. And in that time, we've seen many people go from idea to successfully getting stuff into production, but we've also seen quite a lot of people try and not quite succeed. And so what I'm hoping to do in this talk today is to gather up some of the lessons on the pitfalls and things you might want to avoid, but also the best practices and the things that have allowed people to be successful. And, in the last year, the range of successful applications and attempts at applications for LLMs has just become absolutely enormous. I just had a quick think about possibilities for what things people are using LLMs for today. And we've got everything from code search to language learning assistants, fiction writing assistants, personalized education. But with this explosion of possible use cases and sort of people building this new type of software for the first time, we've also seen a proliferation of new types of problems and challenges. And so that's going to be the core of what I want to talk to you guys about today. And I find it's always helpful to have a specific application or an example to hang your hat on so that we can be more concrete. And so before I dive into the best practices and pitfalls, I wanted to kind of look at one of my favorite LLM applications, which is actually GitHub Copilot. So the reason I like to talk about GitHub Copilot is I think it's one of the most successful LLM applications that have actually made it into production. It's obviously used by over 1 million users and by a quite skeptical audience. Generally speaking, it takes a lot to get programmers to start doing things in a new way. And I also think that they got a lot of the details right and the things right that are needed to build a defensible, really successful LLM application. So I'm going to sort of focus on GitHub Copilot as the example application throughout the talk as I think about the best practices and pitfalls. But this can apply to obviously your own applications and many other things that we've seen in production. So GitHub Copilot has a similar anatomy to many large language model apps. I think most applications built on large language models tend to be composed of LLM blocks with other traditional code. So the other traditional code you already know about, that's your bread and butter. But an LLM block is typically some kind of base model. So this is a large language model that's been pre-trained on the internet, maybe fine-tuned a little bit to a specific task. So that might be GPT-4, it could be Anthropic, it could be an open source model like Llama, and it might have some domain-specific fine-tuning done to it. Then there's usually a prompt template, and the prompt template is an instruction to the model, potentially with gaps for either user inputs or information you're going to retrieve from another system. And finally, there's a data selection strategy. How am I going to get the information that goes in the prompt template? And that's an LLM block. And then most LLM applications are composed of either repeated units of these blocks, maybe composed in an agent, or though these blocks intersperse with normal logic of your application. And so in the case of GitHub Copilot specifically, right, the base model here was the OpenAI Codex model. So that's a 12 billion parameter custom fine-tuned model. So it's a smaller model significantly than either GPT-3 or GPT-4. And that is a deliberate choice in this specific instance because it has to have low latency. They have quite a complex strategy for how they build their prompt template and include user content within it. And it's worth understanding because I think it's a good example of the kinds of complexities that a lot of people we see face. So what GitHub Copilot is doing is they're trying to predict the next few words or characters of your program as you write it, based on the context of what you've recently read or are currently writing. And so what they do is they take the text just behind your cursor, the code that you've just written, and they also take the code in the most recent files you've touched, and they see how similar are those two things. And then they grab relevant snippets of code from the last few files you've touched, put them into a prompt template, and then they prompt the model to generate the next bit of code. And coming up with that selection strategy and deciding how to do that so that the model has your context is, I think, one of the hardest parts of making Copilot correct. And then the other thing that they do, and I'll talk about this a lot more later in the talk, is that they are very careful to capture evaluation data. So they know really well how well it's working. And they do that, as I say, in a way I'll discuss later. And they also regularly fine-tune on the best performing generations. So I think GitHub Copilot is a particularly good example of an LLM app that's successful. And it has a few characteristics that I think make it particularly good. And one is that it works in a fault-tolerant situation. So because it's making suggestions and you can correct them as an end user, that UX is particularly amenable for large language models. And it's quite a novel UX. It's not just this traditional chat or assistant-based workflow. They actually have your context. They're looking at what you're doing. And it's made defensible by having superior model performance through this fine-tuned model, and also by having a network effect through this regular fine-tuning. So I think it's a really good case study of what it looks like to do this right. Okay, so now we have a concrete example in mind that we'll keep referring back to. Let's just chat about, what it takes to build a good LLM application and what is hard about it. So I think one of the hardest things about building an LLM application, probably the root of all of the other challenges, is that evaluation is really hard. It's often really subjective. The things that you're testing are whether or not code is good, or whether an email that's generated is something that you will like. Is it in the right tone of voice? And it's difficult to automatically evaluate those things. I also think that the other parts of building an LLM application that come downstream of this, prompt engineering, is still very much an art, right? Coming up with that prompt template as that component of your LLM application is not very scientific. And because you can't measure things well, it's difficult to know as you iterate on that whether you're making things better. You also have to find ways to restrict the large language models with things like retrieval augmentation to stop them making things up. And then there's sort of more prosaic concerns, right? If you're using a very large model like GPT-4, then latency and cost are often prohibitive for many applications. And it's also difficult to make things defensible if you're just a wrapper around GPT-4. So in order to build a really good LLM application, you have to find ways around each of these problems. And Copilot has done this extremely well, and we'll chat about some other applications as well. And in addition, in order to do these things, in order to solve the problem of prompt engineering and make a large language model that can answer factually and is connected to a retrieval system, you have to navigate just a lot of different decisions along the way of building your LLM app. You have to decide whether to use an open source model or to use one of the large providers like OpenAI. You have to find some way to iterate over prompts. You've got to decide about the structure of your app. Are you going to use OpenAI's tools or agents? Should you be fine-tuning models or not? If you do fine-tune, what data should you fine-tune on? How much? If you're using embeddings for retrieval augmentation, which embeddings should you use? How should you chunk your data? So you have all of these different design choices that ultimately feed together into the performance of your application. You somehow have to find a way to get them right. And those things combined with the difficulty of evaluation are, I think, what makes it hard to build a really good LLM application. So what I want to chat about is basically some of the pitfalls around these areas and some of the best practices that people have got right. And I'm going to focus on 3 areas. One, evaluation, right? Why objective evaluation is so important, why it's difficult, and some of the things you can do to actually overcome it. I'm going to talk about the importance of prompt management, because I think this is something that's actually really underestimated. But if you're not systematic in how you iterate on prompts, it's actually really easy to get lost in a sea of iteration and change that's not actually improving things. And then finally, I want to talk about fine-tuning. I think it's a particularly good moment to discuss fine-tuning because OpenAI has recently released the fine-tuning API for GPT 3.5 and 4. But I think it's actually just GPT 3.5. And I also think that people underestimate the potential benefits of fine-tuning. That's a very common mistake we see. So I'm going to talk about these 3 things in turn, and also about how Humanloop can help you with them. So the first one, objective evaluation, why it's essential, what are the pitfalls, how do you do it better? So firstly, why is it hard, right? So the first reason I think it's difficult is that foundation models and large language models are really general. And so the range of use cases that people apply them to and the inputs that you see in production can be very long-tailed. And so you might test for something in development, you put it into production, and the thing that you see in production has a much wider range of distribution of inputs than you actually tested. And so it's difficult to know upfront if it's going to work well. Then obviously for a lot of developers who are coming to AI and machine learning for the first time because of LLMs, the stochasticity or the randomness is something that's difficult and different from traditional software. When you run these applications each time, you get slightly different results. So you need a different way of testing them. the subjectiveness of the use cases, or subjectivity, is another part that makes evaluation really hard. I mentioned this a little earlier, right? If you're doing email generation, then what constitutes a good email is very subjective. If you're helping someone with a fiction writing assistant, right? What is good? Because it's difficult to define good objectively, it becomes difficult to evaluate and measure your systems. And then because everything is so new, there's also just a lack of well-defined metrics. In traditional machine learning, we have precision, recall, F1, this whole library of metrics we're used to using. A lot of them are less relevant in the case of generative AI and large language models. People will often score really well on academic benchmarks, and that won't correlate particularly to performance in an application. And that's partly due to the first point I made about the generality of the things we're applying these to now. A couple of years ago, most machine learning models did very narrow, specific tasks like classification. But now that we have a single model that might be doing a very broad range of tasks, it's actually much harder to evaluate them. And the academic benchmarks are lacking. I think one of my favorite examples of this is that Stanford has this benchmark, Helm, that was a large language model evaluation benchmark. And in it, they actually look at one of the traditional data sets for summarization testing, which is the CNN and Daily Mail data set. And they found that the model-generated summaries were preferred by humans to the ground truth of that data set. So if you were to use that data set in testing, you'd actually get the wrong answer. And that seems to be like a common problem. And then the last part of what makes evaluation hard is LLMs are typically just one small piece of wider applications. They may be being chained together. They might be being combined with a retrieval augmenting system where you're retrieving information from a set of documents or a database and then feeding it to an LLM. And if you're going to evaluate these applications correctly, you can't just evaluate the LLM part. You have to find a way to evaluate the entire chain. And evaluation matters at every stage of large language model development. So at the prototyping and idea stage, people are typically iterating very quickly. Maybe they use something like the OpenAI or Humanloop playgrounds. They're trying to test the feasibility of their idea. And because the target of what they're doing is moving, rapid iteration is really important. And the criteria that best define evaluation kind of change, right? So you start off with a handful of examples. You're trying to see if something's feasible. Once you know it's feasible, then you start coming up with more specific evaluation criteria to actually measure if it's good. But if you don't have any feedback at that stage of kind of iterating on prompts and in that prototyping environment, it's difficult to know if you're actually going to be able to do the thing you want to do and how to make it better. Then once people deploy to production, evaluation becomes important for monitoring, right? Do you have guardrails in place? How are the models actually behaving in the wild? Is there drift over time? And ideally, you want the tools to be able to drill in on specific cases from production and understand if they didn't go well, why they didn't go well, how much you make them better. And the final place that evaluation, I think, ends up being really important is when you're making changes. And so you have an existing system, you've been running in production for some time, you want to go in and fine tune a model or update a prompt or include a new data set, but you want to be confident that you're not introducing new errors or regressions. And if you want to do it by hand, you have to kind of label a lot of examples. So having some form of evaluation that you can run whenever you make changes that fills in for something like a regression test is really important. So evaluation shows up in 3 different places: prototyping, monitoring, and then checking for regressions when you make changes. And the most common sort of pitfalls we see around evaluation is people just sort of not doing it any systematic way. So like most of the people we see just eyeball a set of examples, or maybe they have a small number of examples they look at, but they don't have a systematic process for evaluation. The other kind of common mistake we see is people will not evaluate their entire pipeline jointly. So they look at maybe just the bits around the LLM, but they won't be evaluating what happens if I change the embeddings, or what is the impact of the embeddings or the retrieval system versus the prompts. And the kind of final 2 is less about specifically how you evaluate, but how you think about designing your application. So you should think ahead and plan ahead. How am I going to be able to capture signals of feedback from my users that will help me understand how well things are working? And you should try and use an appropriate tool. A lot of people we see kind of log things to a database, or they post a Mixpanel, and then they never look really at those analytics. Those tools aren't built for LLM analytics, and so they don't join up nicely. What was the model config? What was the prompt template? How did I do retrieval with the end user feedback that you gather, or with the generations that you gather? And the kind of consequences for this is either people at the first stage, think that a task isn't possible because they don't have good evaluation metrics, or more likely, people spin their wheels a lot, making a lot of changes, tweaking prompts, tweaking embeddings, without actually making any significant progress on how well things are working. And just to validate like how important this is, I was messaging Alex Gravely, who was the creator of GitHub Copilot, and he said to me that baseline evaluation needs to be the core of any AI app, in his opinion. That you have to get this right before you can do anything else. Okay, so how do the best apps that sort of do evaluation well do it? Well, there's really two ways, and I think the first and most valuable one is end user feedback. Because ultimately, because things are subjective, end user feedback is the gold standard on whether or not things have worked well. So in the case of GitHub Copilot, the way that they measure performance is they look at the acceptance rate of suggestions from the model, but they do something a little bit more sophisticated than that. They look at, okay, when someone accepts a suggested piece of code, does that code stay in the code base? And does it stay there at 15 seconds, 30 seconds, 2 minutes, and 5 minutes later? And they're not just looking specifically for the code, like the generation that the thing the model generated. They actually look to see like what's the edit distance between what stays in at different points of time. So do you change it and how much do you change it? So they get a rich signal of, was the model's generation good? Was it accepted? And how good was it? How much of it stuck around? And that then gives them a view into how well the model's actually working, which can then be used to test improvements. If they want to change their prompt template, their data retrieval strategy, they want to fine tune a model, they have a baseline, they know whether or not they're making things better or worse. And it's not just GitHub Copilot that relies on end user feedback. Pseudowrite, a fiction writing assistant, we've seen very successfully get to results using this user feedback. Find, the search engine for developers. Obviously, you actually see it in OpenAI's ChatGPT. So end user feedback in the form of things like thumbs up and thumbs down is really essential. But the best apps don't just capture explicit feedback like thumbs up, thumbs down. They also capture implicit feedback in the form of actions. So in the case of GitHub Copilot, the implicit signal is, does the generation get accepted? In the case of Pseudowrite, they actually look, does the person copy the code, the generation of the story? Do they insert it into their story? Others look at regeneration rates or ask for more detailed feedback. But the best apps we've seen capture both explicit and implicit sources of user feedback. And within Humanloop, we help you do this. And we tend to chunk this up into actions, issues, votes, and corrections. And corrections would just be if you show generated text to a user and they're able to edit it, you want to capture that edit as well. So although end user feedback is the gold standard, there are other ways in which you can also do evaluation and monitoring. One is obviously just having standard sets of evaluation functions for things like latency, cost. You can measure blue and rouge scores on production data. But the other is actually you can also use LLMs to help you run automated evaluation. And the advantage here is that LLMs can look at things that are subjective somewhat better than sort of pure code can. So you can have an LLM read the output and the input to a message and score it in some way. So for example, within Humanloop, we allow you to generate LLM evaluators that either return a Boolean or a number that scores each output from your model. And you can use that either for monitoring or for trying to evaluate the more subjective aspects of outputs. I don't think this is a substitute for end user feedback, but it's a great complement. It can allow you to put guardrails in place. So for example, we have a PII checker that you can switch on. And it can also allow you to check just things like, is the output following a particular schema or stuff like that. So a very common kind of addition to end user feedback that we see people get success with is using an LLM as part of the evaluation workflow. So that's what I wanted to say about evaluation. The other two topics I wanted to touch on were the importance of prompt management, right? And the main pitfall on this one is that people just don't have good infrastructure around prompt management. They're typically splitting things between a playground environment, maybe Jupyter, code, Excel. And the consequences are that it's easy to lose the history of what you try. As different people in your team learn about what kind of prompting strategies work well, it doesn't accumulate learnings across the team. And sort of cycles get spent trying the same things again and again. One kind of common sort of riposte I hear on this is that why can't I just use Git to version these things? I use Git for my code already. And I think Git is a good option for versioning the artifacts around model configurations and prompt management. But often what we've seen is that the teams that are successful have cross-functional collaboration on prompts. They have domain experts or product managers being involved in prompt engineering, and those people tend not to be able to work well with Git. So you really want a solution that allows people to version their prompts, iterate on them quickly, test what matters, and do that across teams. And I think part of the reason that people underestimate the importance of this is they just underestimate how big a difference prompt engineering can have. And I always like to remind people of this, of the chain of thought impact on prompt engineering. So, I think this is about 1.5 years old now, but people just realize that asking a model for reasoning increased the accuracy of question answering by something like 30%. And this is primarily a prompt engineering difference. And this is just one of many different ways in which getting prompt engineering right can have a significant impact on performance. And prompt engineering is also kind of the easiest solution we've come up with so far for being able to get LLMs to be factual, because it allows you to augment a base LLM with information that you retrieve from a set of documents or from a database, and is much faster to change and update than fine-tuning, but does require a lot of iteration on finding good prompts. And so kind of the second big sort of takeaway and best practice, I would say, is that the teams that do well put some kind of system in place and have a tool for doing prompt management well that allows for collaboration between their technical and their non-technical teams. And the last one I want to chat about is fine-tuning. And I would say that the thing I would talk about here is just not to underestimate the potential power of fine-tuning. So the pitfall we see is people just prematurely assuming that they cannot use a smaller model or that a fine-tuned model won't work for them. And the consequence is that they end up having a slower or higher cost model. They have to use a third-party tool like OpenAI, and they don't benefit from the proprietary data that they're collecting in production. This isn't to say that I think people should start with fine-tuning. I think you should always start with prompt engineering. The best teams we've seen push prompt engineering to its limits and then fine-tune. But you should have fine-tuning in mind, and you should be planning for it in the design of your application. You should be designing your application to gather end-user feedback, and then using that end-user feedback for both evaluation and also to drive fine-tuning down the line. And so I think a great case study here is a company I mentioned earlier called Find. And Find have been building an LLM-based search engine that combines retrieval and generation. And they gathered end-user feedback on what worked well, what didn't. And then they used that to fine-tune custom versions of open source models like Llama 2. And they were recently able to get better performance than GPT-4 on their use case through fine-tuning. So you can either get the performance of GPT-4 on a smaller model at lower cost, or you can just get much lower latency and lower cost models by fine-tuning smaller models. And the workflow that we see that works really well is people generate a lot of data using one of the largest models like GPT-4. They then use some evaluation criterion to filter that data, which is why it's so important, again, to objective evaluation. And then they use the filtered data set to fine-tune a model, and they repeat this cycle again. And so you can actually use fine-tuning to actually build defensibility over time, because like the team from Find, you're gathering data from in production that's proprietary to you, and then using it to improve your models through regular filtering and fine-tuning, such that you get a model in your task that for the cost and latency that you have is better than any other model out there. It won't be better in general, but you can get to a level of performance that others couldn't through fine-tuning. And so I'd strongly encourage people to think of fine-tuning and evaluation as closely paired, and of fine-tuning to be an important part in building robust LLM systems. And again, this is a thing that's sort of natively built into Humanloop, supporting this particular flow of being able to gather in production data, filter it based on evaluation criteria, and then fine-tune models on the basis of that and redeploy them to production. So that kind of ends the talk of what I wanted to discuss in terms of the pitfalls and best practices around building with LLMs. And I'd invite anyone who's interested in trying these things out for themselves to please join us on Humanloop. We have a Discord community as well, and we'd love to hear what you're building, help you with it, and hopefully help you achieve some of these best practices that we've been productizing over the last year. Thanks very much.